In the past, many people believed that thunder and lightning were punishments from God. Lightning came from the sky, so they believed that it came from God. It was powerful. It could cause great damage. But no one knew what lightning really was. That changed in 1752. Today's spotlight is on the experiment that showed the true nature of lightning.
Benjamin Franklin was a scientist and statesman. He lived almost 300 years ago in the United States. Franklin is mainly known today as a political person. His writings greatly influenced the United States and many other countries too. But he is also known as a scientist and inventor. His most important discoveries were about electricity.
At that time, electricity was a new discovery. Franklin did many experiments with electricity in his home. He began to think that lightning acted like electricity in many situations. Franklin suspected that lightning was an electrical current, but he wanted to test his theory. He developed an experiment. The experiment would discover if lightning would pass through metal. He decided to use a metal key, but first he had to find a way of linking the key to the lightning high up in the sky.
Franklin's experiment is quite famous. However, Franklin did not record this experiment until much later. So some experts believe that it did not happen the way stories describe it. Scientists debate the details of the experiment. They say that it could not have happened exactly as most people imagine. It is unclear how Franklin actually did the experiment. But Franklin's results are clear. Later experiments proved that he was correct. Most modern versions agree that it happened something like this.
The story says that Franklin decided to use a kite. We usually only see children playing with kites. They like to make them using brightly coloured paper, sticks, and very thin string. They stretch the paper over the sticks and attach the string to the sticks. And then they hold onto the long string and run. The wind carries the kite through the sky.
Franklin made his kite from light cloth. He tied a metal key to the bottom. He expected the lightning to strike the kite. He believed that the lightning would flow down the kite string to the key at the end.
The experiment took place in Philadelphia, Pennsylvania. It was June 1752. Franklin and his son waited for a thunderstorm. When the storm began, they carried the kite outside. They flew it high. It entered a rain cloud. Franklin put his hand on the key and then, bang! Electricity flowed through. The experiment had worked. The lightning behaved like electricity. It flowed through wet kite string and the metal key.
Some modern scientists say that the lightning would have killed Franklin, but they do suggest other possible ways that the kite experiment could have happened. For example, they suggest that lightning did not strike Franklin's kite. They say that the string got electricity from the air in the storm.
No matter who is right about the details of the experiment, Franklin's theory still caused many people to investigate lightning. Now, scientists agree that lightning is electricity, and scientists know much more about lightning. They tell us that
on average, there are 100 lightning strikes every second around the world.
Lightning can send out 1,000,000 volts of electricity. The temperature in a lightning bolt is about 30,000 degrees Celsius.
Lightning can strike in half a second. In that time, the lightning heats the surrounding air. It heats it to an extremely high temperature, 5 times hotter than that on the sun's surface. The heat causes the air to expand. This makes a sound. We hear this sound as thunder. Although this happens at the same time, we hear the thunder after the lightning. The reason for this is simply because sound travels more slowly than light.
Lightning disappears quickly in the air, but it does sometimes leave something behind. Fulgurites. The word comes from the Latin word for lightning, fulgur. The best known fulgurites are sand fulgurites. These are found under the surface of sand.
Sand fulgurites form when lightning hits sand. They are thin glass tubes under the sand. The heat from the electrical current is very intense. It melts the sand into glass. Fulgurites usually take the shape of the roots of a tree. The outside of the thin tubes is silica glass. Scientists can easily make silica glass in laboratories, but it is very rare to find it in nature. Fulgurites are not usually longer than a few centimetres. This is because movement of the sand often breaks the fine tubes. They are, after all, glass.
Rock fulgurites form in a similar way. They form when lightning strikes the surface of rock. The lightning melts the rock's surface. It can also melt the inner part of the rock. Rock fulgurites are even less common than sand fulgurites.
The formation of Fugurites shows just how powerful lightning is. Lightning can cause great damage to buildings, especially tall buildings. Benjamin Franklin invented something simple to prevent this damage. His invention is called a lightning rod. Lightning rods are tall, thin pieces of metal. A rod may have a pointed end or a ball at the end. People place lightning rods at the top of a building. The rod is the tallest thing on the building. A wire goes from the rod to the ground. When lightning strikes, the electricity goes through the rod to the ground. The lightning does not affect the building. Lightning rods became very popular because of Franklin. They have saved many buildings.
From electricity to a lightning rod that saves buildings, Benjamin Franklin asked questions. He changed ideas, and he invented something that still helps people today. All discoveries start in the same place. What questions do you have? What can you create?